Okay, now let us discuss power set. What is power set? All possible subsets of the given set is known as power set. What does it mean? Let me take one example. A is a set 1, 2, 3. Let me write all the subset. So first I will start from the nothing, null set. Then after 1 is another set. Then 2 is another subset. 3 another subset. Now 1 and 2 another subset. 1 and 3. Then 2 and 3. Then 1, 2, 3. Why these are said to be subset? Because 1 is belongs to A, 2 is belongs to A, 3 is belongs to A, 1 and 2 belongs to A, 1 and 3 belongs to A, 2 and 3 belongs to A, 1, 2, 3 also belongs to A. So set of all possible subsets group is said to be power set, including null set. So now, how many possible subsets we may get? Suppose the number of elements of a set is m. Let us discuss. There is a note. Now you understood, I think, what is power set. It is denoted by P of A. How many power set? 1, 2, 3, 4, 5, 6, 7, 8. All together we should write. First null set, after 1, after 2, after 3, then after 1 and 2, 1 and 3, 2 and 3, then 1, 2, 3. This all together is nothing but power set. Then n of P of A means number of power sets. N of P of A. So how many subsets we can write? 1, 2, 3, 4, 5, 6, 7, 8. That is 8 number of subsets we can frame for this set A. Now there is an nodes. Let us discuss those nodes. Here, if number of elements of set A is m, then number of elements for that power set of same set A is equal to 2 to the power of m. What does it mean? Suppose if I take a set A is A, B. Here how many elements it has? 2. So how many subsets I can able to write? Total how many subsets I can able to write? That is nothing but 2 to the power of m. If you substitute 2 as it is, m place, there are 2 terms in the set A. Therefore number of term is 2. 2 power of 2 is nothing but 4. 4 subsets we can write for this, which are A, B, AB alone, then one more null sets. These are P of A, means power set of A, means including null set, one term, again 2 terms, totally 1, 2, 3, 4. How many terms we are finding? Number of power set is equal to 4. 1, 2, 3, 4. 4 subsets we can write. So P of A is nothing but A comma B comma A comma B and null set. There are 4 terms, so 4 subsets we can write. A alone subset of A, B alone subset of A, AB subset of A, null set is also subset of A. Okay. The next note, the second note, this note says the number of proper subset of set containing n elements is 2 to the power of n minus 1. The number of proper subset of set containing n elements. If I assume one set A is 1 and 2. So how many subsets I can write? 2 power of 2 is nothing but 4. Let me write all 4 subsets. B equals 1, C is 2, D is 1 and 2, and E is null sets. Right? So total 4 subsets we can make. B is subset of A, C is subset of A, D is subset of A, E is subset of A. Here superset also there, proper set also there. If you want to know what is superset, just go back to the previous part and check. Here B is subset of A, but A and B are not equal, so this is called proper. 2 is subset of A and C are not equal, so it is proper. And null set also subset of set A and they are not equal, so this is proper. Now this set D is also subset of A, but this is A and D. In this, A is said to be superset because A and D are having same elements 1, 2, 1, 2. D is subset of A means A is said to be superset. But how many proper set we are getting? 1, 2, 3. Because AB are not equal, AC are not equal, AE are not equal, but B, C, E are subset of A. Then A has 3 proper sets, 1 superset. So A is superset of D, A is proper set of B, C, E. So how many proper set we found? 3. How to use this formula? Here how many terms are there? 2. Apply. 2 to the power of n plus 2 minus 1. 2 power of 2 is nothing but 4. 4 minus 1 is nothing but 3. There are 3 proper set. Understood? So the number of proper subset of set containing n element is 2 power of n minus 1. They may expect this kind of questions in exam. Answer is 2 to the power of n minus 1. Suppose the set containing 3 elements. Set containing 3 elements. Instead of 1, 2, you can take one more element, 7. In this case, how many proper set we can get? 1, 2, 3. Substitute. 2 to the power of 3 minus 1. 2 power of 3 is 8. 8 minus 1 is 7. See, one set, if you find the subset, if you find the power set, there one superset will be there definitely. Rest of that are proper set. So how many possible subsets we can find? That case 2 power of m. 2 to the power of 1, 2, 3. In that 8. Out of 8 subsets, 1 will be superset. That superset, if you eliminate, remaining 7 will be proper subset. Okay, na? If you want, I will show you. 1 alone, 2 alone, 7 alone, 1 comma 2, 1 comma 7, 2 comma 7, 1 2 3, sorry 1 2 7 and null set. So 1 2 3 4 5 6 7 8. 8 subsets we can write, but in this will be superset. A is a superset for this. Rest of that A will be proper set. So how many proper set we can find means 2 to the power of n minus 1. Here 8 subsets we can find. In that one will be superset for A. Rest of that proper set for A. Okay, na? Now let us discuss universal set. Yeah. What is universal set? All sets under consideration will be subset of a fixed set is called universal set. Means all the subsets, when you join together, you will get one set. That set is nothing but universal set. For example, this universal set is denoted by U symbol, or this mu symbol, or this symbol also we can use for universal set. Example, I am taking B is 1 2, C is 3 5 7. Then U will be 1 2 3 5 7. Means B is subset of U because 1 2 is here. C is subset of U, 3 5 7, it is here. These two subsets elements together is nothing but universal set. Universal means it's a large set, larger set than the subsets. When you combine all the subsets, you will get universal set. Now let us discuss equivalent set. What is equivalent sets? Let us take an example. Suppose A I am taking 1 2 3. B set I am taking A B. If you want, you can take some other elements or numbers only you can take, no problem. 4 5. So number of elements of A and number of elements of B are not same, then it is not an equivalent. Then what is equivalent? If I take one more element here number of element is 3, number of element of B is also 3. Here also 3 elements, here also 3 elements. Therefore, number of elements of set A and number of elements of set B are equal, then these two set is said to be equivalent set. So very simple way we want to understand means the elements can be different but number of elements must be same in both sets. Then it is said to be equivalent set. Next, equal set. What is equal set? In this equal set, what does it mean? I will give an example. I am taking a set A is 1, 2, 3. Set B also 1, 2, 3. Now, number of elements of A set and number of element B set are same, and also element also same. 1, 1, 2, 2, 3, 3. Number of elements should be same and elements also same. Then A is equal to B. When it is number of elements of both sets must be same and element also must be same. That is, then set A and set B are said to be equal sets. Okay. Now next we need to discuss operation on sets. Okay, now